Okay, so we're going to be graphing functions and finding the transformations, domains, and ranges, particularly with radicals. Okay, so the key here is we want to try and get numbers that give us a perfect square. It's going to make it easier for us to graph. So when I choose my x terms, I chose -5, -4, -1, and 4. Let's move this up. And the reason I chose those numbers is it gave me a 0, it gave me a 1, it gave me a 4, and it gave me a 9 under the radical. So, -5 plus 5 is 0, the square root of 0 is 0, 0 minus 2 is -2. When I plug 4 in for x, -4 plus 5 is 1, the square root of 1 is 1, 1 minus 2 is -1. -1 plus 5 is 4, square root of 4 is 2, 2 minus 2 is 0. And 4 plus 5 is 9. The square root of 9 is 3. 3 minus 2 is 1. And I want to graph those points. Now, -5, 1, 2, 3, 4, 5, down 2. -4, -1, -1, 0, and 4, 1 is my graph. Now, if you'd like to write the parent graph down, you can. Those are points 0, 0, 1, 1, 4, 2, and 9, 3. Okay? You don't have to write the parent graph down. I want to see an accurate version of this graph. And then we're going to work off of this graph to get our domain and our range and our transformations. This graph starts with the x coordinate at -5, and it goes to the right. Therefore, the domain has got to be greater than or equal to -5. The other way you can write the domain if you want would be this. Bracket -5 to infinity. You can write that as well. For my range, once again, I'm reading the graph. I'm at -2, and it's going up. So my range is y is greater than or equal to -2, or a bracket -2 to infinity. And then my transformation is represented by 4 things. 1, a shift left or right. 2, a shift up or down. 3, is there a reflection over one of the axes? And 4, is there a shrink or a stretch? Okay. A negative sign in front of the radical or in front of the x is what represents a shift over the x or y-axis. There's none of that here. We don't have to worry about it. A number in front of the radical sign is vertical, stretch, or shrink. A number in front of the x term is horizontal, stretch, or shrink. There's none of that here. And then our adjustment, when we add and subtract to the x, and when we add and subtract outside, represents our shifts. What makes the radical equal to 0? -5. Hence, you're going left 5. This -2 out here with its sign represents vertical, represents vertical shift. So in this case, it's down 2. So in this transformation, it's just a shift of left 5 down 2. There is no vertical stretch or shrink. There is no reflection. Okay. So this graph of g of x is the cube root of -4x plus 1. So here we got a lot more going on. With the cube root, I want to try and get perfect cubes under the radical. So I'm no longer looking for 0, 1, 4, 9 under the radical. I'm really looking for 0, 1, 8, 27, maybe 64. I'm looking for perfect cubes to put on the radical. And that's how I determine my x's. By plugging -2 in, I get +8. The cube root of 8 is 2. 2 plus 1 is 3. By plugging -1/4 in, I get a +1. We should know how to get a 1 by multiplying by a coefficient. Negative 4 times negative 1/4 gives us 1. The cube root of 1 is 1. 1 plus 1 is 2. If I plug 0 in for x, cube root of 0 is 0. 0 plus 1 is 1. You plug 1/4 in for x. Now this is where a cube is unique to a square. Negative 4 times 1/4 is negative 1. We can take the cube root of a negative number. So in this case, we get the cube root of negative 1 plus 1. That's negative 1 plus 1. That's 0. And finally, negative 4 times 2 is negative 8. The cube root of negative 8 is negative 2. And negative 2 plus 1 is negative 1. And I'm going to plot these points. Negative 2, 3. Negative 1/4, you do the best you can. 2. 0, 1. 1/4, 0. 1/4, 0. And then 2, negative 1. Now, we should have an idea of what a cube root graph looks like. If you feel like you need another point there, you can always put it in, okay? If I put 16 in for x, and the reason I would choose 16 or negative 16, 16 times 4, negative 4 times 16 is negative 64. Negative 16 times negative 4 is 64. So let's say we got 64 under that cube root. The cube root of 64 is 4. The cube root of negative 64 is negative 4. All right, if I plug in negative 16 in here, I get 64. The cube root of 64 is 4. 4 plus 1 is 5. So negative 16 is somewhere out here. This is where the 5 is. Okay. Positive 16 gives me a cube root of negative 4 here, because negative 4 times 16 is negative 64. Cube root of negative 64 is negative 4 plus 1 is a negative 3, so I'm somewhere out here. We should recognize that that's what the cube root graph looks like. Okay? And reading it off the graph, the domain and range are all real numbers. You're going to infinity in both directions. Now, you can write it like that, or you can write it like this. It's really your option. One is not better than the other. Okay? Now, there's no A term. So there's no vertical shift, and there's no reflection over the y-axis. This is where there is stuff. There is a term in front of x. Now, it's on that sheet Miss Ayala gave you. Okay? Horizontal stretch is different and shrink is different than vertical. Vertical is a little easier to deal with. Vertical, we just take the number. Horizontal stretch, we take the reciprocal of the number in front of x. So in this case, it's shrink by a factor of 1/4. Okay? You take the reciprocal of the number in front of x. And if it's negative, we reflect over the y-axis. If it's positive, there's nothing. But if there's a negative in front of the x, you're reflecting over the y-axis. Here's why. If I were to draw the parent graph looks like this. This one is shrunk a little bit because it's pushed together horizontally. But if you notice, this graph is flipped over the y-axis. This graph is flipped over the y-axis. So when you have a negative in front of your x term, you reflect over the y-axis. So our transformation here, there's no right or left because there's no number under the radical that we're adding or subtracting to. We added 1 outside the radical, so it goes up 1. There's a negative in front of the x, so we reflect over the y-axis. And we have shrink by a factor of 1/4. And I should put something else in there as well. I apologize. We have horizontal shrink by a factor of 1/4. Okay, the vertical shrink comes when you have the number outside the radical, or outside the exponent. Next one. Now we have 2 times radical x minus 3 plus 2. Okay. When I get my points, once again, I'm looking to get points that give me perfect squares. 3 minus 3 is 0. 4 minus 3 is 1. 7 minus 3 is 4. And 12 minus 3 is 9. 3 minus 3 is 0. 2 times 0 is 0. Plus 2 is 2. 4 minus 3 is 1. The square root of 1 is 1. Times 2 is 2. 2 plus 2 is 4. 7 minus 4 is 4. 7 minus 3 is 4. Excuse me. Square root of 4 is 2. 2 times 2 is 4. 4 plus 2 is 6. 12 minus 3 is 9. The square root of 9 is 3. 3 times 2 is 6. And 6 plus 2 is 8. So 3, 2. 4, 4. 7, 6. And unfortunately, we're going to fly a little bit off the graph. I'll put it there. But this is my graph. And I should be able to read that graph from a domain and range standpoint is going from 3 to infinity on the x-axis, from 2 to infinity on the y-axis. Once again, you can write 3 to infinity. You can write 2 to infinity if you so choose. This graph is going right 3 up 2. 3 makes the radical equal to 0, and we have the positive 2 out wide. Now, this a term out here is 2. That represents vertical stretch or shrink. With the number outside the radical, we take that number straight up. We don't need a reciprocal of it. The vertical stretch is 2, and there's no negative in front of it. If there was a negative in front of it, we reflect over the x-axis. There's no negative, there's no reflection. So a negative either in front of your x or in front of your radical, or x cubed, is what determines whether there's a reflection or not. There's no negative, you don't have to worry about it. If there's a negative there, then you do have to be worried about it. So this problem right here, we have a x under the cube root. So I'm going to use perfect cubes. The cube root of negative 8 is negative 2. Negative 2 times negative 1/2 is 1. 1 minus 3, or 1 minus 3 is a negative 2. So negative 8, negative 2. Okay. Put a negative 1 under here. Cube root of negative 1 is negative 1. Negative 1 times negative... negative 1, cube root of negative 1 is negative 1 times negative 1/2 is 1/2. 1/2 minus 3 is negative 5/2. So we have negative 1, negative 5/2. Like, oops. Yeah. Okay. We put the 0 in there, we get negative 3. We put positive 1 in there, we get negative 7/2. And then finally, we put 8 in there. Cube root of 8 is 2 times negative 1/2 is negative 1 minus 3 is negative 4. Yep. And there's my graph. Okay, in this graph, all reals, negative infinity to infinity if you want. The cube root graphs are going to be all reals for domain and range. This is vertical shrink. When there's a number less than 1 in front of the radical, that represents vertical shrink. The last problem, when a number bigger than 1, that was vertical stretch. This is vertical shrink. There's a negative, so we reflect over the x-axis. Vertical shrink, we reflect over the x-axis, and we're going down 3. There's no number under the radical that we're adding or subtracting to the x. It's just a minus 3 on the outside, so we're going down 3.